Hello everyone, this is Sanchayan from ISOEH. Today I am going to discuss about the topic steganography, the art of data hiding. This is a very interesting topic and I am going to show you how can we uh, hide the data inside any other file like image file, video file or audio file. Okay, so now today I'm going to cover all this topic, introduction part about the steganography and what is steganography, why we use this steganography, and also some steganography algorithm. So this is not possible to discuss about all the steganography algorithm in details. I am trying to discuss at least one steganography algorithm for better understanding and visualization. Okay, and after that I will also show you the steganography tools, different steganography tools by which one can hide and unhide the data from other file like image, video or audio. Okay, and lastly we conclude about the steganography. So steganography, the word steganography comes from the Greek word, okay, steganography. So stegan means basically covered and graphy means writing. So both together, covered or secret writing. That is the meaning of the word steganography. So that means covered some secret message and writing it inside the other file. So it basically use under some images, video, audio and maybe sometimes inside other file as well. Okay. So the steganography is basically defined as the science or even possibly art of hiding the critical information or sensitive information with within other information. That means other file, mainly inside the image file, audio file or video file. Okay. The point of steganography is to prevent the detection of information leakage and not encrypt the data. Both are different. So however, there is nothing stopping a user malicious or otherwise from first encrypting a secret message and then embedding it inside the harmless information. So the process only deals with embedding one bit stream, that is the hidden information, inside the other bit stream. Okay, so either bit stream can be of any form. However, the steganography is frequently used in conjunction with cryptography, but this is not necessary. One can only use the steganography and can hide a plain text inside the other file. Okay, so in one method, the plain text would first be encrypted and then hide or feed into the steganography program, and this ensures that if the hidden message is retrieved, the plain text will still be in encrypted form. So they need to be decrypted it to get this particular plain text message. So in other way, one can directly hide or embed the plain text message inside the image file or maybe other bit stream. That means inside any other file. Okay. So that these two technologies that sometimes closely related and perform together, okay, to steganography technique, and our watermarking and fingerprinting and many other technologies are also used for steganography. Now, before the invention of digital means, that is the traditional method, were being used for sending or receiving message. Before phone, before mail, before horses message were sent on foot. Okay, so for the message where privacy was a prime concern, so the ways of implementing the security, they use some procedure, choosing the messenger capable of delivering the message securely and writing the message using citation that actual meaning of the message was concealed and hiding the message such that even its presence cannot be predicted. Okay, so in recent days, this type of thought or this type of technique can be implemented is implemented in digital file and also using the digital message, right? So steganography is basically the technique of hiding the message in a chosen carrier such that no one expect the intended recipient is aware of its existence, and the recipient only can get that secret message from that file where the data is actually been hidden. Okay. Now there are numerous methods used to hide the information inside the image or maybe inside the audio or video. Okay, so there are few algorithms are available for hiding the data inside the image. Like least significant bit algorithm is one of the best algorithm for steganography technique to hide the data inside a image file. Other than this, fingerprinting and watermarking and also masking and filtering, such kind of algorithm is also been used for steganography technique. Now I'm going to discuss in details about the LSB algorithm or least significant bit algorithm. When files are created, there are usually some bytes in the file that are not really needed or at least are not that important. Okay, so these areas of the file can be replaced with the information that is to be hidden without the significantly altering the file or damaging the file. It can hide the data inside that file. So this allows a person to hide the information in the file and make sure that no human could detect the change in the file. The LSB method works best in the picture as I told previously, and that have a high resolution and use many different color. If the color if the color depth and the uh, image size is higher, then it has the larger capacity to store the more information inside that particular file. Okay. So and with the image file that have many different format and that are of the resolution. So the LSB method usually does not increase the file size, but sometimes we can see the file size is increases, but this is depending on the size of the information that is to be hidden inside the file, and the for image file compression is also very important, and depending upon the compression the file size is also matter. Okay. So usually 24-bit or 8-bit files are used to store digital image. Okay, so before going to know the LSB algorithm, first you need to know about the image, how a image is stored digitally inside the computer memory and what is the representation of that. Okay. So usually a 24-bit or 8-bit files are used to store the digital image. The former one provide more space for information hiding. However, it can be quite large. The colored representations of the pixel are derived from three primary colors, that is RGB: red, green and blue. So 24-bit image use 3 byte for each pixel. So where each primary color is represented by 1 byte, that is 8 bit. So using this 24-bit image, each pixel can represent a huge number of color values. So we can use the lower 2 bits of this color or maybe lower 1 bit of this color channel to hide the data. Okay, so then the maximum color change in a pixel could be of 64 color value or maybe only one color value. Okay, so but this cause so little change that is undetectable for the human vision system. So this simple method is known as the least significant bit method or least significant bit algorithm. Now let's elaborate this. So before going to elaborate the LSB algorithm, first I'm going to elaborate how a digital uh, image is represented. Okay, so now see, suppose there is a image with the resolution of 800 cross 600. So in that case, that particular image is represented digitally by a matrix of the dimension of 800 cross 600. Okay, and each and every element of that particular matrix is represent the pixel. So the value of each and every element of that matrix is represented its color value, right? So now I'm just draw a simple image structure. Okay, so let's open a word file, simple word file. So now think about there is a image of a very small dimension, right? That is dimension of 8 cross 8, suppose. Okay, so it basically represented by a matrix of 8 cross 8. Okay, so Suppose think this is a matrix. So suppose there is an image which dimension is 8 cross 8. So this is represented by the matrix 8 cross 8, and each and every element of that matrix represent its the corresponding pixel color. And if it is a 8-bit representation, then the color space is vary from 0 to 255, that is total 2 to the power 8, that means 256 different color combination. Okay, so this is a simple concept of permutation and combination. If there is 8 bit and we try to arrange 0 and 1 in this 8 bit, 0 and 1, because in computer memory the data is stored in the form of 0 and 1. So in 8 bit minimum we can store 80, that means the minimum value is 0, and maximum we can store 81, that is the maximum value is 255. So total 2 to the power 8, that means 256 different color combination we can get for a particular pixel if it is a 8-bit representation. Now if it is a 16-bit representation, then we can get 2 to the power 16 different color. So that is from starting from 0 to 2 to the power 16 minus 1. Okay, and this is only for a grayscale image we use a single matrix. Okay, but if the image is a color image, that is a RGB image, so we can get 3 such matrix. One matrix is for red, another one is for green, and another one is for blue. And by mixing the color value of each and every pixel, it represent a final color. Okay, so now suppose for example, think the first color value is pixel value is 129. Okay, now suppose next one is suppose 65, next one is 64, next one is 128, so on. Okay, so this way each and every pixel have its own color value. Okay, so now in computer memory it basically represented by 0 and 1, and this is a 8-bit representation. So now I am showing you the representation in the computer memory. So it's a 8-bit representation. So the binary of the 129 is, I think it's 1 0 0 0 0 0 0 1. Similarly, the next pixel value is represented in 8-bit like this: 0 1 0 0 0 0 0 1. Now go to the next pixel. Now this is represented by 1 0 0 0 0 0 0. Okay, so and so on. So now this is the representation of an image in the computer memory. Now suppose there is a text apple. So we are going to hide this particular text inside the image. So our first task is to take each and every character from the text and convert it to the corresponding binary. Okay, and the representation is a 8-bit representation. So first take the character A, and convert it into binary. So how can we convert this into binary? First, we need to convert this into the corresponding ASCII value. So the ASCII value of capital A is 65. Now convert this value into the corresponding binary, and that is in 8 bit. So 0 1 0 0 0 0 0 1. So this is the corresponding binary of the character A. Okay, and the representation is in 8-bit representation. Similarly, next we need to convert the character P into the corresponding binary, and it's a small p. So the corresponding ASCII value is 112, and convert this into binary. So the binary value is 0 1 1 1 0 0 0 0. Sorry, it's 0 1 1 1, then 0 0 0 0. Okay, so similarly again we need to convert this into the P into the corresponding binary, so the result is same. Then L, then E. So total we got 8 into 5 bit, that is 40 bit long binary. Now our aim is to store this binary value into the pixel value. So now we use the concept of LSB, that means the least significant bit. Okay, so within this 8 bit, which one is the least significant bit? The rightmost bit is the least significant bit. That means if we change the rightmost bit, then the change in the number is minimum, and from the right to left, if we change the position, then the value is increases. That means if we change the leftmost bit, then the change in the number is maximum. I am giving you an example. Suppose 100. Okay, think about this. Suppose 100. So if you change the rightmost bit by increase by 1, so then the number is increased by 1 from 100 to 101. Now if we change this one, then the number is changed by 10. Means if we increase the second number by 1, then the total number increased by 10. Similarly, if we change the leftmost bit, okay, by 1, that is from 1 to 2, then the number change by 100. Okay, so this one is the most significant bit, leftmost bit, and the rightmost bit is the that is the least significant bit. So here in the pixel value, if you change the rightmost bit, then the change in the pixel is minimum. Okay, so to store all these character, the binary form of this character, we replace this into the LSB of each and every pixel. So first store the character A, so the first bit is 0. So replace this by 0. So the pixel value changes from 129 to 128. Then next we need to store 1. So the least significant bit of the next pixel is already 1. So no need to change this. So the next pixel value remains same. Then next one is 0. So here the least significant bit of the next pixel is also 0. So no need to change this. Okay, so make this same. So 64. So similarly, if we store in the next pixel, then this is also be same. Okay. So this way, to store a single character we need 8 pixel, and in the LSB least significant bit of each and every pixel we store only 1 bit. This way, to store the word apple we need total 40 pixel. Okay, so for a image, for a real image, the resolution is around over 200, 300, 800, even 1500, 1600 also, 2000 also. So think about that, how many pixels are there. So we can easily store a huge amount of data inside that particular image. Okay, so this way we can store a character or text inside a image by means without a significant change. So if the color value of a pixel is changed by 1, so this is not possible to identify the change by a human vision. Okay, so the image looks like same, but inside that particular image we can successfully able to store the text, and if the image is a RGB, then the capacity to store the text is larger, right? And in video, of course we know video is nothing but the combination of still images, right? So if we play 25 to 30 still images per second, then it become a video. So this way, inside a video we can also store the text. Okay, we can also hide the text. So similarly, there are some other algorithm is also there, like fingerprinting and watermarking. So these technologies are mainly concerned with the protection of intellectual property. Thus the algorithm have different requirements than the steganography, right? So this requirement of a good steganographic algorithm will be uh, like in watermarking, all of the instances of an object are marked in the same way. The kind of information hidden in object when using watermarking is usually a signature to signify the origin or ownership for the purpose of copyright protection. So with fingerprinting on the other hand, different unique marks are embedded in distinct copies of the carrier object that are supplied to different customers. So this enables the intellectual property owner to identify customers who break their licensing agreement by supplying the property to third parties, right? So in watermarking and fingerprinting, the fact that information is hidden inside the files may be public knowledge, but sometimes it may even be visible, while in steganography the imperceptibility of the information is crucial. So a successful attack on a steganographic system consists of an advisory observing that there is information hidden inside a file, right? While a successful attack on a watermarking or fingerprinting system would not be detect the mark but to removal it. Now masking and filtering method is also there. It is a cryptography technique which can be used on uh, each bit per pixel image. Okay, 24 bit per pixel image. The technique can be used on both color and grayscale image. The masking and filtering is similar to placing the watermarks on a printed image. Okay, so this way one can also hide the text inside a image. So now there are different algorithm is also available for audio. Sometimes all the frequency are not audible for a human being, right? So we can also add some uh, extra information in that frequency which cannot be audible by a human being. So this way we can also hide the uh, information, crucial information inside a audio file, right? So this is the different algorithm, but if you want to learn all these algorithm in details, then you need to research about all these things and you need to study about all these algorithm. Okay, now we can also use some tools to perform the steganography technique, right? So there are different tools are available, like QuickStego or OpenStego are available, in which we can hide the text or crucial information inside a image. Then StegoSpy is also there, which is basically find out that in any image file is there any steganography technique is used or not. DeepSound is also there, by which one can find is there any information is hidden inside a audio file or not. Even we can also hide and unhide that audio file, uh, hide and unhide the text file from that audio file. Our secret is basically used to hide the information inside a video file. Okay, so now I am going to show you some of these tools by which we can perform the steganography technique. So first I'll show you the tool QuickStego. So here is the tool QuickStego. Now first I will show you how to hide the messages or how to hide the crucial information or important information inside a particular image. So first we need to open image. So now suppose I am going to open this image. Okay. Now here we need to write the text or the information which we want to hide. Okay, so write the message, then you need to click on the button hide text. and it also say that this image does not have a quick stego secret text image. Okay, then hide text. The text message is now hidden in image. Now what to do? Now I need to save this particular image. Save image, and you can put any other name. Okay, and save this. Okay, so now exit from here. So now we are successfully able to hide that particular information or text inside the image, and here is my new image. Okay, now compare these two images. And see these two images for few seconds, and try to find out is there any difference between these two images. So the answer is no. But in the first image there is nothing is hidden, but inside the second image some information, some text is hidden. So now we need to perform the next phase of the steganography, that is called the steg analysis. So in steg analysis part, we analyze the image to find out is there any message or text or information is hidden inside the image or not. If yes, then we need to find out that. We need to find out that secret message from this. Okay, so for that we need to again open the tool Quick Stego. So here is my tool Quick Stego. Now open the image which you want to check. So this time I am going to open the image in which I hide the message, this one, Stego picture, and open. And see, you can get the text or the secret message which you basically hide inside this particular picture. Okay. So sometimes the different terrorist group are also use this technique to exchange the secret message between them without disclosing this to any other authority. Okay, so now this technique is also used from the aspect of a criminal also. Means suppose sometimes some criminal may want to hide his evidence, okay, and he want to store some secret, means store some illegal things or some trace of illegal task inside his computer or mobile, whatever he want. So in that case the suspect or criminal may also use this type of technique, steganography technique, by which they can hide the information about their illegal operations. Okay, so this is something called anti-forensic technique. Okay, in the field of the computer forensic. Okay, so in the field of computer forensic this is also very important, and for that purpose we need to defeat this anti-forensic technique to actually get back the secret message which the suspect or the criminal is hide inside this type of file. Okay, so from the aspect of a forensic investigator, this steganography or steg analysis is very important. Okay, so now I'll show you example. I have few uh, picture, okay, and I am trying to analyze all these picture to really find out is there any secret messages hidden inside any of that image or not. Okay, so to find out is there any secret messages hidden inside the image or not, so for that we can use the tool StegSpy. Okay, so here is my StegSpy tool. So first open this and here is my some text, here is some images in which we need to find out is there any steganography technique is used or not. So try from the first one. Okay, so you selected this particular image and sorry, no steg found, so nothing is hidden inside this particular image. Okay, so now second one, steganography found at marker position 24023, hidden program detected. Okay, so something is hidden inside this particular image. Okay, so in the next steps I'll show you how to find that particular message, secret message which is hidden inside this image. Okay, let's check the next images. Next image, sorry, no steg found. Next one, sorry, no steg found. PNG, sorry, no steg found. Same, okay, same, no steg found. This one, there is also no steg found. So this way we need to check each and every message if there any secret message is hidden inside a particular image or not. So we see that this one have something, that means some message is hidden inside this particular image. Okay, so our next step is to find out the hidden message or secret message from this image by stego analysis. So for that we'll use the tool OpenStego. So here is the tool OpenStego. By using this tool one can hide the secret message inside another cover file, or he can also extract the secret message from a particular cover file. Okay, so this time I'm trying to extract the data from that particular image file. Okay, so go to the tab extract data and then input the stegos file. Okay, so give here and put maybe suppose this one also show. Okay, and you need to output folder for the message file, means where you want to store the output, suppose in the desktop. Okay, and now extract the data. So the file testing.txt is already stored. So now check the desktop for the secret message. Okay, here is the file. So see, now we got the secret message which is hidden inside that particular image. Okay, now check for the other images. Sorry, go to image file. Put this in desktop. Extract the data. So message file successfully extracted from the cover file, and we got this one. So this way we can check whether the any secret message is hidden inside a particular image or not, and further we can also extract that particular hidden message from the image. So similarly, I will also show you another tool that is called DeepSound. So by using this tool, one can hide and unhide the secret message inside a audio file. Okay. So here is my tool, DeepSound. So now, see, first we need to open the carrier file. Then you can add the secret file to hide any secret messages inside the audio, or if something is hidden inside that particular carrier file, carrier audio file actually, then you can also extract the secret file. Okay, now suppose I have few audio files. Okay, now I am going to check, is there any secret message is hidden inside any particular audio file, yes or no. Okay, so check from the first one. Check this one. So it's reading this particular audio file. So nothing is actually hidden inside this particular audio file. Okay, so if something is hidden, then it will show here. So now go for the second one. You can also add some secret file inside this image from here. Okay, so this time I'm going to find out, is there any secret file is hidden inside any audio file or not. Now choose the second one. Okay, so this one have some hidden secret messages, and the file name is showing testing1.txt. Now next select this one and then extract the secret file. So the secret file is decoded to user unknown document. Okay, so you can check in the document file. Yeah, here is the file. Okay, so this one is actually hidden inside this particular audio file. So this way you can check the remaining audio file also to check whether there is any hidden messages are there or not. Okay, so third one, nothing is there. Then fourth one, no, nothing is there. Fifth, no, nothing is there. Sixth, I think, no. So there is only one file. Okay, that is dangerous.wav, which have some secret message inside this particular image. So this way we can also use the tool DeepSound to hide and unhide the data inside a particular audio file. Okay, similarly, you can also use the tool Our Secret to hide the secret messages inside a video also. Okay, so now hope you all understand about the steganography technique. Okay, and if you want to know further and if you want to uh, work with this, then you need to research and you need to know about all the algorithm and the procedure in very details. Okay, so now lastly I'm conclude this session. So the steganography has its place in security. It is not intended to replace the cryptography, but sometimes it may supplement it. So hiding a message with steganography method reduce the chances of a message being detected. However, if that message is also encrypted, if discovered, it must also be decrypted. Okay, so this is another layer of protection. So there is an infinite number of steganography application are there. Okay, so it goes well beyond the simple embedding text in an image. Steganography does not only the pattern to digital image but also to other media file, right? Like video, audio, as I told, and other text and binaries also. So other media such as communication channel, the list you can check from any other source. Okay. So other than this, so steganography also have a aspect of the digital forensic investigation to defeat the anti-forensic technique like steganography. We need to use some stego analysis to find out the evidence from a suspect images or maybe other files. Okay, so this is a very important topic and important technique for both the aspect from the aspect of the security, information security, as well as the computer forensic or digital forensic. Okay, so that is the all about the today's session about the steganography. Okay, and thank you all to listening me, and thank you everyone. And if you uh, reach try to reach us, then here is all the details. You can check this, and for further details you can contact with us. Thank you everyone.